All right, so now in this example, this one's real important because it's going to be real similar to your homework number 8. Um, go to the whiteboard. All right, so this one's going to be real similar to homework 8. It's going to be a coffee shop example. This is in a 4.4 using special distributions on the PDF. So a coffee shop wants to know the probability that they'll break even in any given week. They have overhead of $1,325 per week. About $2,150 per week in sales, and the cost of goods sold is about $745 per week. The average customer spends about $835, so $835 per customer, and they have about 242 customers per week. So that would be the average. So let's write all it down. So all of these are weekly numbers. Weekly numbers. We're just going to write down everything that we have. So they have overhead of $1,325 per week. So I'm going to say overhead of $1,325 per week. And about and in sales, again, all of this is per week, average per week. They have $2,150 per week in sales, and the cost of goods sold is about $745 per week, and all of these are averages. So the average customer spends, let's say, average customer spends $8.35 per customer. Now, let's say on average, they have 242 customers. They have 242 customers per week. That is our average. So assuming customers per week follows the same distribution, let's assume all weeks are exactly the same. What is the probability of breaking even or better? So let's pretend you're a consultant working for this company. You want to know the probability of breaking even or better. So breaking even is an event. The break even or better is an event. So we want to know break even or better. So what is this? Well, how would this event be classified, or what would this event really be? Break even means net income is equal to 0. So you didn't make any profit, you didn't lose any profit, but net income is 0. You want to break even or better, though. That means net income would be equal to or greater than 0. But we don't have a distribution of net income. But maybe we do for customers. We know that customers, we get 242 per week. So let's think about what that distribution could be. Maybe we already know. So let's say X is the number of customers. Let's say it follows a Poisson distribution with an average of 242 customers per week. So let's look at our distribution, our distributions from the PDF. So it's a discrete. The number of customers per week is a discrete, and let's say it's Poisson. So let's look at Poisson distribution. So in order to be a Poisson distribution, the number of possible occurrences in any interval is unlimited. So you could have 0. You have to have at least 0 because it's countable. You can't have negative many customers per week, but you could have 0 customers in a given week. You could have infinitely many, but you're not going to. You probably wouldn't have more than several hundred. The number of occurrences in one interval does not affect the number of occurrences in other intervals. So let's assume all weeks are independent, which this may not completely represent reality, but let's just for the sake of this example, let's assume that each week is completely independent. So the number of customers you have in the first week does not affect the number of customers you have in the next week. So the number of customers is independently, so the number of customers per week is independently and identically distributed, and it follows the Poisson distribution. The average number of occurrences must remain the same from interval to interval. So it's the same average every single time. It's the same average every single time. So we don't know the we don't know a distribution for net income, but we know the distribution for the number of customers per week. So let's figure out, let's get this in terms of units that we understand. So what is the formula to break even? The formula to break even is going to be your overhead divided by 1 minus your gross profit margin. The gross profit margin is going to be your COGS divided by sales. So this is on a per weekly basis. It would be 1,325 divided by 1 minus 745 divided by 2,150. And this is going to be about $2,027.58 dollars. This is per week. So you need about $2,027 per week in order to break even. Again, we don't have a distribution for net income, but we do for the customers per week. So let's figure out how many customers we have per week, or I'm sorry, let's figure out how many customers we need per week to break even. So we know we have, this is where dimensional analysis will come in more handy, which we talked about at the beginning of this module. So this is $2,027.58 per 1 week. We need to get this in terms of customers per week, so it can follow the Poisson distribution. So we need to divide it by 835, which is per customer. I'm sorry, this is 8, which is money. Then this is per customer. So this would get it in the units that we need. So the dollars will cancel out. And then we have customers per week. So this is going to be equal to, this is not something I do quickly in my head, but this is going to be equal to some numbers per week. So now we can calculate the minimum of customers that you need. But remember, whatever this is, whatever this number is, you need it to be rounded. So if this is the number, let's say it's 240.3, whatever it is, you need it to be rounded. If it is not rounded, then I'd say it's 240. So let's say it's 240 or 240.3. You can't have 240.3 customers per week. It's either 240 or 241. So if this was 240.3, you can't have 240.3 customers. And then we want to know to break even or better. So if it's 240, if we just round it to the nearest integer to 240, you didn't break even. We want to know the probability of the event of breaking even or better. So in order to break even or better, this has to be rounded up. Round up. So we're going to do what's called a ceiling. So we're going to do this. It's kind of like an absolute value where you round it, or no, you don't round absolute value, but the ceiling, we do these brackets, the upper half bracket, we're just going to round to the nearest, the next high, or to the highest integer. So if it was 240.3, 240.3 would then become 241. So this is, and this in Python, it would be numpy.ceiling. All right, so now we know what we're going to do. Now let's actually do it in Python. So I'm going to go to a new share. I'm going to go to my notebook file. So now we can actually solve for it. We can actually solve for the number of customers necessary to break even. So our overhead was 1,325. Our cost of goods sold was 745. Our revenue, and all of these are weekly numbers, it's 2150. The average revenue per customer was $8.35, and the average customers per week is equal to 242. So now the break even. To break even, it would be the formula overhead divided by 1 minus our COGS divided by our revenue. This would be our break-even amount. Let's say customers to break even would be equal to, remember we want to do the ceiling. So we want to round up. We're going to do a break even divided by revenue per customer. We're going to put that in ceiling. So now we're going to get customers to break even. We get 243. So we round it up. So the amount of customers necessary to break even or better must be 243 customers in a given week or greater. So now we want to find the probability of breaking even. We want to find the probability of breaking even or better. So I'm going to bring this back up. The probability of breaking even or better would then be could be described as the probability of having number of customers in a given week to be 443 or greater. Remember, we're going to do a CDF of this. So to do a CDF, we would want to we're going to want to do the probability of X being equal to or greater than 243. The CDF comes from the left, so it's this number or less. So this would be 1 minus the probability of X being less than 243. But remember, this is discrete. You can't have 242.5. You can't have 242.1. So we're going to say this is the same as 1 minus the probability of X being equal to or less than 242, which also happens to be the mean. So now we can actually solve, and we can calculate what is the probability of breaking even or better. So let me go back to our notebook file. Now we can solve. So let's do the probability. The probability of 243 or better. We would do 1 minus stats.Poisson.CDF. We're going to do a cumulative density function. We're going to say K is equal to the customers necessary to break even. Customers to break even. It'd be to break even minus 1 because it's going to be 1 less than that. And our average is going to be the customers per week. Look at this, and we get a 48.29% probability of breaking even. So in any given week, if they're all follow the same, if they're all ID, then you have a 48.3% probability of breaking even or better. If we were to plot this out, one more thing. Remember, if we're going to plot it out, let's go from 175 to 325. Let's say for Y, we're just going to plot out the Poisson distribution X with an average. So we're going to show what this distribution actually looks like and what we did. Then we're going to plot it. I'm going to do the bar X and Y. So what we did, make it a little bit larger so you can see a little bit clearer. Figure, fixed size. I'm going to make it a 10 by 5. So what we did was we added up all of these to the right. So about 242? So 242 or greater. We added up all of those, and this would give us our probability 48.3. So you could add up everything to the right of that number, or you could add up 1 minus everything to the left. If you did it right in the middle, then it should be about 50%. You can see with the Poisson distribution, typically it doesn't look quite this much like a normal distribution. For smaller numbers, hopefully they have a, yeah, here they go. So here for, this is for 2. For smaller numbers, it doesn't look like a normal distribution, which you would have seen in another stat class. But as the number gets larger, as average gets larger, in this case, the average is relatively large, it's 242, it looks real similar to a normal distribution. But remember, a normal would be a continuous, and Poisson is discrete. So we counted up all the customers from 243 or greater, or we added up 1 minus the probabilities of everything of 242 or less. So this is, we found the probability of breaking even. This is real similar to the homework assignment that you're going to have at the end of the module. This will be it for this one. The next one, we'll do portfolio returns.